Hi, statistics. This is chapter 2 homework. So there's a couple things that you want to realize. Same thing here. We have that question help in different pieces. After constructing a relative frequency distribution summarizing IQ scores of college students, what should be the sum of the relative frequencies? So relative frequencies, what is a perfect score on a test? 100%. So percentages should sum up to 100%. Proportions should sum up to 1 because proportions are going to be the numbers in decimal form. 100%, if the percentage sign leaves, the decimal point goes 2 places to the left. So 100% is the same as 1.00. So when we get into identifying class widths, midpoints, and boundaries, what's going to happen is we are going to have on this one a daily low temperature. So the class width is going to be how wide the class is. So first you have to determine what is the class. Here, the daily low temperature is the class. Frequency is a count. So when you think frequency, think about a count. So my classes, I have 1, 2, 3, 4, 5, 6, 7 total classes. And the first class is 32 to 36. So even if you need to use your fingers, you're going to have 32, 33, 34, 35, 36. So if we count, 32 is 1, 33 is 2, 34 is 3, 35 is 4, and 36 is going to be 5. So how wide is the class? The class is 5 wide, and every single class is going to be 5 wide. 37, 38, 39, 40, 41. So that also has a class width of 5. Class width has to be consistent all the way through. What are the class midpoints? So the class midpoint is going to be the number in the middle of the class. So here, since my class width is odd, what's going to happen is it's just going to be that number in the middle. 32, 33, 34 is right in the middle of that first class. That's my first class midpoint. 37, 38, 39, my third number in is going to be the middle of the next class. So who's going to be the middle of my third class here? 42, 43, 44 is the middle of that class. And you're going to do that for each of all the classes. So my class boundary is almost always going to have this 0.5. And what it's going to be is, you notice how 1/2 before 32 is 31.5. And then right in between 36 and 37. So my upper class limit of my first class is a 36. My lower class limit of my next class is a 37. Right in between 36 and 37, 36.5. Right in between 41 and 42, 41.5. And that's going to be true all the way, 61 and 62, 61.5. And then 0.5 above my 66 is 66.5. So you have to make sure you get a class boundary before the first class and after the last class, and then in between each of the classes. So this is asking me to create relative frequencies. So what I'm going to do is I'm going to click on this right here, and that's going to give me the data. There's this little box right here. If I click on that, I can open it in Excel. So as I open this in Excel, it's going to give me that my data. So what I can do is I can insert in between. That way I can get my relative frequencies. What I do is I need to have a sum here equals sum of. So that's going to tell me that I have 25 total items here, which we can see. We have 2 plus 14, which is 16, plus another 6, which is 22, plus another 3 is 25. I also want to get a sum over here, equals sum of. And then what we're going to do is we want to know the percentage. So I have equals 2 divided by 25. And so if I put a shift 4, a dollar sign in front of that 7, what's going to happen is it's going to lock it. And then I'm going to be able to copy those pieces down. And remember what we learned in the last piece? These should all add up to 1.0. And then I can do the same thing over here. I'm going to do my 3 divided by the 25 that we have here. I want my dollar sign so that I'm always dividing by that 25. And my sum needs to equal 1.00. And so what I'm going to do now is my TAR for my non-filtered cigarettes is 0.08. 0.08 as a percentage is 8%. When I come back to my homework, what I'm going to see here is I have to double check all my pieces along the way. You notice my first class here is 15 to 20. That means I have 0 non-filtered in 3 to 8. I have 0 non-filtered in 9 to 14. The first class I have data in is this 15 to 20. 15 to 20 is 0.08, which is 8%. My next class, 21 to 26, is 0%. 27 to 32, 0.56 was my calculation. That's 56%. 33 to 38, 0.24 is 24%. 39 to 44 is 0.12, which is 12%. I then needed to do the same thing with my filtered cigarettes. And so when I go back to my filtered, what we're going to see is the class from 3 to 8, I have 0.12, which is 12%. Class from 9 to 14, 0.12 is 12%. 15 to 20 is 0.28, which is 28%. 21 to 26 is 0.48, which is 48%. You notice I have nothing in 27 to 32, 33 to 38, or 39 to 44, so those are all 0. So as we go through, you can use Excel to calculate this, or you could have added up within your table and then just did the division by a calculator. So the next question is asking about cumulative frequency. So cumulative is going to be what? As you accumulate things. So you're going to accumulate your buckets. So between 20 and 29, you had a frequency of 25. They want less than 30. So in my group of less than 30, there's 25 total things. My next group wants less than 40. Well, that's going to be the ones in 20 to 29, which is 25, plus the ones in 30 to 39, which is 35. 25 plus 35 equals my 60. Less than 50, I need to add all the groups that are less than 50. 25 plus 35 plus 14. So I can start with the 60 I had plus my 14, which is 74. We're going to accumulate in the buckets all the way to the last group, which is going to be less than 90, which will be the 25 plus 35 plus 14 plus 3 plus 4 plus 1, which I would have already calculated as 82, plus the 1, which will give me 83. So in a group like this, what they want me to do is they want me to create those frequencies. So they have my groups here, 15 to 20.9. So they want me to count how many of my data points are between 15 and 20.9. I have 1, and then I have 2, and then I have 3. And so the 17.7, 18.3, and 19.2. So then I put a 3 here. I would then count how many I have between 21 and 26.9, 27 and 32.9. So what this one is this is going to be what? This is not quantitative data, but it's qualitative data, but I can group it. They want to know the relative frequency of blood group A of 0. And so as I go through, what are we going to have to do? We're going to have to summarize this. We have to find out how many O's we have, how many A's we have, how many B's we have, and how many AB's we have. Then we're able to add them up, and then we have to find the frequency, the relative frequency. Divide the number of O's divided by the total number of items we have. So you have access to a very powerful statistical tool in here, and it's called StatsCh2Part1. So if I click on this, and it's going to say open in StatsCh2Part1. So when I open in StatsCh2Part1, what I'm going to do is my first step, I'm just going to leave my data. I want to hit Stat, go to Tables, and go to Frequency. I need to click on VAR1 because that's my variable 1. And then I only wanted the relative frequency. So I'm just going to click on relative frequency there, and I'm going to say compute. And what it's going to tell me here is A is 0.225. So if I move my decimal 2 to the right, that's 22.5%. A is 22.5. And when I go back, I'm going to see AB is 0.05, AB is 5%, B is 0.1, 0.10, B is 10%, and O is 0.625, so 62.5%. Just make sure that you match up letters by letters because it's going to put this in alphabetical order, whereas this is not in alphabetical order. So this is asking about blank are sample values that lie very far away from the majority of others. So they're called outliers. They lie outside of the other data points. So outliers lie outside of other data points. So what this wants you to do is this gives you a histogram and it wants to know how many members it represents. So in this group, we come back and it's 1. And because you see how my scale, they label 2, 4, 6, but I have 1, 3, and 5 in between. So I have 1 plus there's 5 here, so that's 6, plus 3 more is 9, plus another 3 is 12, plus 4 is 16, plus 2 is 18, plus 4 is 22. So for each of the groups, we want to do what? We need to come back to our scale to figure out how many are in each of those groups, and then we need to add them all up. So here they're asking about the class width. So each class is represented by its own bar. So there's one class from 110 to 120, but you notice the next class is from 120 to 130. So the class width here is 120 minus 110, which is 10. The approximate lower class limit here is going to be what? That 110, and the approximate upper class limit is going to be 120 of that first class. So the first part of this group is asking me which of these histograms represents this data. So one thing I know is I can start at the very left. From 3 to 3.49, I should have a frequency of 1. Well, if I look at this guy, that first group there from 3 to 3.49, that's more than 5. He's definitely not right. This guy's about 3. He's definitely not right. So that only leaves this piece right here. And if we look along the way, the next guy should be 6, the next guy should be 12, the next guy is 15, and then I have 20, and then I come back to 11, I come to 8, and I come to 3. Sometimes students are helped if they take a piece of paper and put it on their screen to line them up. So when it comes to distributions, a bell-shaped distribution is going to be called a normal distribution. And then you're going to have some that are going to be smaller on the left. If the data has smaller numbers, frequencies on the left, it's skewed left. If it's smaller on the right, it's going to be skewed right. And if it's all the way straight through, that's going to be called a uniform distribution. So this is a stem plot. And so the thing that's a little tricky with a stem plot is we are going to have that the hundreds and the tens place is going to be represented on the left-hand side here. That's our stem. And then our leaf is going to be the ones place. So here, what's going to happen is this right here, this 9 with a 0 would represent a 90. This 9 with that 0 would represent another 90. And this 9 with the 9 would represent a 99. That would tell me that in my data set, I have 2 90s and a 99. Do I have 2 90s and a 99 in my data set? I don't. The only 9 I have for 90s is 91. So that tells me either B or C could be correct. But then I get into my hundreds. And this tells me I have 100, 100, 100, 100. So that tells me I have 2 100 data points. This tells me I have 100, 100, 105, 105, 105, 105, 106, 106, 108, 108, and 109, 109. But if I look at my data set, the only things that I have is I have a 100 and another 100. So at this point, I already know B is my only possible. So one of the things you have to be careful with on something like this is the colors do not always match up. You notice blue is T here, blue is T, blue is T, and blue is T. That's obviously the biggest, so any of them could be correct. But let's look at the gray. The gray is V